Alright, let's talk about imaginary numbers, shall we? So, imaginary numbers are when you multiply two numbers and then you get a negative number. Now you're probably thinking to yourself, that doesn't make sense. If you multiply a positive times a positive, you're going to get a positive. And if you multiply a negative times a negative, you're going to get a positive because the negatives cancel. But we have this special number, we call it I. And I equals square root of negative 1. Now, you've probably seen before that you can't take a square root of a negative number. It just doesn't work that way. But with I, it represents this number, this imaginary number, in which that would work. So, using this idea, if we square both sides, I squared equals negative 1. You can see here that we finally have a number that when squared equals negative. And that's just the basic concept of imaginary numbers. Okay, now let's do a couple of example problems that are a bit easier, like addition and multiplication is a bit easier than multiplication and division, but we'll get there. So, with addition, we want to just add this as you would with regular numbers. You just have this sort of, you could call it a variable I now. So, let's add the ones that aren't i's together. 2 plus 1 is 3. And then let's add 3i minus 6i, which would be negative 3i. So it's pretty simple. Now for subtraction, 5 minus negative 4, that would turn into a plus. That would be 9. Negative 2i minus negative 1i would be negative I. So addition and subtraction is a bit easier. So let's go on to multiplication and division. Okay, so suppose you have this problem here, and it's asking you to get rid of this I at the bottom. And you're probably wondering to yourself, how do I do that? I mean, I can't do this. The way to solve these problems is always simple. You just multiply it times I over I. And the reason for this is that we want to cancel these i's, because we know that I squared equals negative 1. So we can just apply that property and get rid of the I at the bottom. So, if we multiply, we're going to get 3i over 2i squared. 2i squared is negative 1. So, 3i over 2 times negative 1, we end up getting 3i over negative 2. And that's how you solve a problem where it asks you to get rid of the I in the bottom. Okay, so now we're going to do a multiplication problem, and like this one, you would do it any other way if you were to have something like 2 minus 3x times 3 plus 4x. We're just going to treat it the same way. So I is just a variable. Let's just leave it at that. And then when we get into like better, simpler terms, then we can deal with I. So let's set up a box. Write 2 minus I, 3 plus 4i. I like putting the signs just so I'm not mixed up. So 2 times 3 is 6. 2 times 4i is 8i. 1 times 3 is negative 3i. Negative I times 4i is negative 4i squared. So let's write this out. 6 minus 3i plus 8i minus 4i squared. Simplify it. 6 plus 5i minus 4i squared. Okay, so this may seem like a logical place to stop, but we have I squared. Now, do you remember what I was? I equals square root of negative 1. So, it only makes sense for I squared to be negative 1. If you square both sides, you're going to get this. So, we can now use this property to finish up this problem. So, it would be 6 plus 5i. Now, if this is going to be negative 1, this negative 4 is going to change into a 4. So we end up getting 6 plus 5i plus 4. 6 plus 4 is 10. 10 plus 5i. And that's how you multiply together imaginary numbers. Okay, so now let's solve this problem. This problem is asking us to divide the two following complex numbers. So the way to do this is that you find the conjugate of the bottom number and then you multiply both sides by it. So a conjugate is just going to be this, but with the signs flipped. So like this is positive, so it's going to be 7 minus 4i. If this were to be negative, the conjugate would be 7 plus 4i. So we multiply both sides by 7 minus 4i. And this is where it gets a little, you gotta do a bit of work, but we'll get through it. So we're just gonna set up the same thing we did for the first multiplication problem and just, I'll speed through it. So 35, negative 20i, 14i, negative 8i squared. So the top is 35 minus 20i plus 14i minus 8i squared. Now the bottom, do the same thing, but with the bottom, a couple of things are going to cancel, because you can see plus 4i minus 4i, so just a heads up, minus 28i, 28i, so you can see that the 28s are going to cancel, minus 16i squared, so just write that entire thing out, plus 28i minus 16i squared. So now let's just combine like terms, so 35, that's minus 6i minus 8i squared over 49. These two cancel because they're positive and negative, so minus 16i squared. So now we're left with these I squareds in both the numerator and the denominator. But using that previous property of if I equals square root of negative 1, then I squared equals negative 1, we can simplify this. So the top, 35 minus 6i minus, so we have negative I times negative 1. Negative times negative, positive 8. Over 49 minus negative 16 times negative 1. Negative times negative, positive, plus 16. Now let's just simplify this a bit more. So this is going to be equal 43 minus 6i over 65. That is our fully simplified answer, and that's how you divide two complex numbers.